complicated problems, so we divide this tape up into two parts. Part one, dealing with trig equations. All right, let's look at now how we need to approach this. What I want to do is to review you on working algebra, and then all we're going to do is say, in place of x's here, we're going to have sine of thetas, or tangent thetas, or secant thetas. So we're going to go through the same process that you're supposed to know from algebra of how to solve equations. Well, one of the first examples is if you have 4x squared equals 3, how do you solve this? A method is to divide both sides by 4, get x by itself on one side. Listen to that sentence. What we want is x on one side by itself. And we go solve, and whatever it comes out to be, that's the value for x. So in this type of problem, what we do is divide by 4, then we take the square root of both sides. Square root of x squared is x, square root of this is the square root of the top, which is square root of 3, and the square root of 4 is 2. So we took the square root of the top, square root of the bottom. And we put a plus and minus sign out here because of two answers. There must be two answers for this. If we have x squared, then we have to have two answers. If we have x cubed, we must have three answers. So whatever this power is, we're supposed to have that many roots. So therefore, we put the plus and minus out in front to have the root plus the square root of 3 over 2 and the root minus the square root of 3 over 2. We do not put the plus and minus here because the square root is plus and minus. That is not true. Okay, we stick the plus and minus on here to have two solutions to this problem. All right, so if we're solving an equation that has an x squared, doesn't have an x in it, then this is a method. All right, now let's look at that in terms of trig equation. Well, trig equation, here's the same thing. It's 4x squared equals 3. So what do? We divide by 4. We have this squared. Now you need to understand the cosine squared is actually the cosine of theta squared. That's what it is technically. That's what it is if you have to do calculator work. You can't go put in the square button here on the calculator. You have to do in parentheses cosine x parentheses then squared. So therefore the cosine of theta squared is equal. So we take the square root of both sides, we get cosine, and here we get plus and minus the square root of 3 over 2. Now in the textbook, most of these problems will be these special angles. So what we need to do is go experiment. We're going to do, or if you already know these, we're going to do 30 degrees. 30 degrees is 1, 2, square root of 3. Okay, or we're going to do 45, 1, 1, square root of 2. Well, there's the square root of 3's and 2's, therefore it must be that one. Now, is it 30 or 60? Well, the cosine of 30 degrees is a side adjacent over the hypotenuse, so it must be 30 degrees. Aha, so therefore, this is 30 degrees. But wait a minute. This is where the calculator won't work for you, all the angles. Cosine is the square root of 3 over 2 in quadrant 1. There's 30 degrees. But what about quadrant 4? Quadrant 4, 30 degrees, or 330 degrees, is also a positive square root of 3 over 2. So that means then we better add 330 degrees. Well, now, anyway, that's just the positive square root of 3 over 2. What about the negative square root of 3 over 2? Well, let's see. Negative is over here 30 degrees, and here 30 degrees, and therefore we get the 150 and the 210. Now listen to me closely again. Here's what I'm saying to you. This is the way I teach this in the related angle section. This is the way you need to learn it. The cosine of theta is square root of 3 over, forget the plus and minus, is the square root of 3 over 2. You then go to your special angles, or your calculator, and figure out what angle that is. That's 30 degrees. Then you come back and use the chapter on related angle and say, okay, 30 degrees from here, 30 degrees from here, 30 degrees from here, 30 degrees from here. This is 30, this is 150, this is 210, this is 330 degrees. And if you'll notice in the notes, if you look there, you'll notice the last step is to put them in order. Put 30 first, and then 150, 210, and 330. But the way you get those, the first line I have is the positive gives us 30 and 330. The negative gives us the 150 and 210. You see, your calculator will not give you all of those. It will only give you the 30 degrees, okay, or the 150 for the minus. So we need to know trig to be able to get all the angles. Well, what this is saying is if I put the cosine of 30 degrees in here, yeah, square root of 3 over 2. If I put the cosine of 150, it's minus the square root of 3 over 2. If I put the cosine of 210, it's minus the square root of 3 over 2. If I put the cosine of 330, it's positive square root of 3 over 2. So here I have 4 answers to this when dealing with trig, because most problems, not all problems, but most problems, if you're given a trig function of an angle is equal to a number, you have 2 choices, okay, because different quadrants. Now, if there's special numbers like the 0 degrees, 90, 180, 270, then you only get 1 angle. All right, so to review this real quick is to look at this cosine as just like it's an x and think of it as working algebra. Then when you get to this step, you go back now to trig and figure out the angle. Or use your calculator. Your calculator will give you, what you need to do then is hit the inverse cosine button. That second cosine button. Hit the inverse cosine button and then put the square root of 3 divided by 2 equals, and it will give you this angle. Then you have to come up with the other angles by 30 degrees here, 30 degrees here, 30 degrees here, 30 degrees here. Okay, let's look now at example 2. The second basic algebra process is if you have an x squared and an x. No constant in here, just an x squared and an x. The way you should work this algebraically is you move everything to one side, set it equal to 0, and solve. Okay, well, when you do this, what you're supposed to do is factor. If you have a common factor here, you factor it out, and so we get x times a parenthesis. Now, the rule is, listen to the rule now, not just the letters. The rule is if this times this is equal to 0, then you set this part equal to 0, and you set this factor equal to 0, and then you go solve it. So setting this equal to 0 and solve, we got it. Setting this equal to 0 and solve, we move the 3 across, divided by 4, so we now have it solved. But again, pay attention to the process. If you had a sine squared and a sine up here, tangent squared and a tangent, then you move that across, and that becomes a common factor, okay? Then you set each factor equal to 0 and solve. All right, let's look at that same setup with trig functions. Here we have 4 sine squared is equal to 3 sine, so we'll move that across, set it equal to 0, and solve. Well, we have a common factor, so we'll factor it out. We set that equal to 0, we set this equal to 0, and solve. So setting that equal to 0, well, there it is. Setting this equal to 0, we move the 3 across, divide by 4, and so we have the sine of theta. Now, what angle is a sine of theta 0? That's the way you read this. What angle is a sine 0? Well, let's see, that's 0 degrees. 0 degrees, 0, 1. So the sine is y over r. So that would be, excuse me, there's my mistake. That's 1, 0. Okay. This point x is 1, y is 0. So sine is y over r, it's 0 over 1, so it's 0. So 0 degrees. Well, also 180. Now your calculator is going to show you this. On this, if you hit that inverse sine of 0 equals, you will get 0 degrees. The calculator will not give you the 180. 180 is minus 1, 0. Y over r, 0 over 1 is 0. So this one gives us 0 degrees and 180 degrees. All right. Now this one, sine of theta is equal to 3/4. Well, that's not one of our special angles. That's not 1, 2, square root of 3. That's not 1, 1, square root of 2. So it's not either one of those. Therefore, this must be done with the calculator. So what we must do is hit the inverse sine button, that's second sine button, and then 3 divided by 4 equals, all right? So I'm going to do that with my calculator. I'm going to do inverse sine of 3 divided by 4 equals, and it shows to be, let me erase this, this shows to be 48.59, or rounded off 48.6 degrees. Now in the notes I have it written as minutes, okay? And all that's for is if the textbook requires you to write it as minutes. That should be old-fashioned going out of business, because nowadays we have calculators and we can write this thing correct to 5 or 6 decimal places, keep it in storage, and have it to use. So we'll just write this as decimal. So that's 48.6 degrees. But wait a minute, that's not the only answer, okay? Where is the sign a positive 3/4? Okay, the sign is a positive where? Quadrant 1 is positive and quadrant 2 is positive. So it's 48 degrees here and it's 48 degrees there. So we have to come along with the other angle. So we subtract this from 180 and we'll get what? 131.4 degrees. All right? So therefore, listen closely, this gives us these two angles and this one gives us these two angles. Okay, let's look now at example 3. Example 3 is saying, okay, what do we do if we have x squared and x and a number? Okay, if we have all three there. Well, the rule is you move everything to one side, set it equal to 0, and solve for x. Well, in this example, we can solve by factoring. The fourth example that we'll look at here in a minute, it won't factor. Well, if it won't factor, we use a quadratic formula. So we do that. All right, but this will factor, so we factor it. Set each factor equal to 0. All right, so setting this equal to 0, in solving, we move the 1 across. That's a -1 divided by 2, so we get x is equal to -1/2. Setting this equal to 0, moving the 1 across, we get x is equal to 1. So the process here is, listen, if we have an x squared and an x and a number, constant, then we get everything to one side, set equal to 0. If it can be factored, factor it, set each factor equal to 0, and you got it solved. Okay. If it won't factor, use the quadratic formula. Or use the quadratic formula to start with, whatever you need to do to get the job done. All right, now let's look at the trig process of looking at this. What happens if we have 2 sine squared minus sine equals 1? Well, we move it across, get everything equal to 0. Factor. Well, we've FOIL method. Okay. 2 sine of theta, 1 minus 1, works out, checks. Set each factor equal to 0. If we set this equal to 0, move the 1 across, makes it a -1, divide by 2, and so we have the sine of theta is a -1/2. Here we move the 1 across, we have the sine of theta is equal to 1. All right, again, we now come down and say, okay, what's theta? Well, -1/2. Minus. The minus says sine is y over r, so that means quadrant 3, y is negative, quadrant 4. So when you punch your calculator and you do the inverse sine of -1/2, you're going to get a -30 degrees. That's not the answer. It's 30 degrees, but it's where? Well, 30 degrees here is 210, and 30 degrees over here is 330. All right, or we can use our triangle. 1, 2, square root of 3. 30 degrees, sine is side opposite over the hypotenuse, so it's 1/2. So it's at 30 degrees, but the minus says it's 30 degrees here, y is negative, and it's 30 degrees here. All right, sine of theta is equal to 1. Well, wait a minute, that's one of those special angles, okay? So let's go look at 9 degrees. 9 degrees is 0, 1. Sine is y over r, that's 1. So this is 9 degrees. And that's it, not two angles, because 270 is a -1. So when we get the special angles, sometimes we only get one angle for that answer. All right, so that means these three angles will work up here. And you should learn to rewrite them in order, ascending order. So put 90 and then 210, 330. All right, let's look at example 4. Example 4 is saying, okay, now it won't factor this time, so what do we do? Okay, so if we have this quadratic, move everything across, set it equal to 0, and we have this and will not factor, we don't want to factor. Just start out with quadratic formula. Then you have to remember this. Quadratic formula is a minus b, the number in front of the x is the b, plus or minus b squared minus 4a, which is the number in front of the x, times c, which is a constant, all over 2a. And so we plug it in. Minus 5 minus this minus a minus 5 makes it a plus 5. Okay. Then a minus 5 squared is 25. And then minus 4 times a is 1 times a minus 3. All right, so this minus 4 times a minus 3 is a plus 12. So we get the square root of 37. So we have 5 plus or minus square root of 37 over 2. Then if you take your calculator and do all that arithmetic, then you get 5.54 for the 5 plus the square root of 37 divided by 2. And then 5 minus this, you see this answer is 6 point something. Okay, so this minus that's minus 1 point something divided by 2 is a minus 0.54. So we get those two answers. Quadratic formula. All right, now let's look at the trig statement of this same process. We have sine squared minus 5 sine of theta minus 3. So now wait a minute. Over here we said what was right here and what was here? X. What's right here and what's here? Sine. So we put sine of theta equals, not x equals. We put the sine of theta equals. And it's still the same thing. All right? So it becomes the same calculation. We do the exact same numbers over here on the right side of the equation. The difference is we have the sine of theta instead of x. So when we come down here and get the sine of theta is the 5.54 and minus 5.4, we mark this one out. Why? Because the sine and cosine can never be greater than 1. So if this decimal value is larger than 1, that gets marked out. And so we only deal with the minus 0.54. So again, we go to the calculator and we hit inverse sine of a negative 0.54. And we end up with a minus 32.68 degrees. Whoops. That's not the answer we're supposed to write. All right, this is 32. Let's just call it 32.7. Now wait a minute. Sine is negative. That means quadrant 3 and 4. So what we're looking at then is 32 degrees here and 32 degrees here. All right, so 32 degrees here is added to 180, so that makes that 212.7 degrees. And over here it's 360 minus that, so that makes that 327.3 degrees. All right, so this we do inverse sine button, and to find that number, then we have to go use quadrants to determine the final answer. Okay, now let's look at example 5. All right, looking at example 5, we have 2 tangent squared plus 3 secant. Oh, no common factor. We do have it set equal to 0, but we don't have any common factor. Now here, listen to this sentence. These problems are trying to say to us, these next 2 or 3, is you get the rule where you get all to be the same trig word. We want all the same trig word. Now, the take part 2 is dealing when these angles are different. What do you do there? And that rule is you get all the same angle. But this rule is you get it all to be the same trig function. All right? So we do that with a trig identity. So in place of tangent squared, we put secant squared. What, minus 1? Remembering tangent squared plus 1 is equal to secant squared. So tangent squared is equal to secant squared minus 1. Plus 3 secant theta is equal to 0. All right? So here we have 2 secant square root of theta plus 3 secant theta minus 2. Now here's what I did. 2 times this and then 2 times the minus 2. Well, I'm going to move it over here. And I put that secant in there because now what do we have? We have the same thing as 2x squared plus 3x minus 2. Okay? So we have 2 secant squared plus, so we might be able to factor that. Well, let's see if we can factor it. Factoring, let's see. Experiment here, we're going to put a 2 secant theta, and over here we'll put secant theta. And we'll put a 2 here and a 1 there, all right? First times the first, that's okay. Last times the last, that's okay. And in the middle term, we want a plus 3. So if I put a plus here and a minus there, does it check? Sure enough, this added to that is, and so we do it by factoring. If you do not want to factor it, use your quadratic formula, where this is B, this is A, this is C. All right, so that equals 0, so therefore we set this equal to 0. Excuse me. And we set this equal to 0. All right, setting this equal to 0 and solving, we get secant of theta is equal to positive 1/2. Over here, we get the secant of theta is equal to minus 2. All right. Whoops. We marked this one out. Why do I have the check there? Because the secant and cosecant is never less than 1. Sine and cosine can't be bigger than 1. Secant and cosecant can't be smaller than 1. So that one gets marked out. So we deal with this one. All right, well, secant is a minus 2. Forget the minus. Secant is 2. So we come over here and do our 1, 2, square root of 3, and check 30 degrees. Secant is hypotenuse over, oops, that's not it. Okay. Let's go to 60 degrees. Secant is hypotenuse over adjacent. Oops, sure enough, that's 60 degrees then. So therefore, our angle is 60 degrees here, or here, or here, or here. Secant is r over x. X is negative. Therefore, it's these two angles. Therefore, our final answer then is 60 degrees here, which is 120 degrees, and 60 degrees here, which is 240 degrees. All right, so that's the process there. All right, let's look at example 6. Example 6 is, oops, I've got to get to be the same word. So we use our trig identity. Secant squared is 1 plus tangent squared. Plus tangent equals 1. Well, moving this 1 across, what happens is we get tangent squared plus tangent. Okay? So what do we do here? This was example 2 in our algebra process. We have a common factor, so we factor it. Set each factor equal to 0. And I'm going to go ahead and solve this in one step on the tape. Set this equal to 0. Move this across, be a minus 1. Okay? All right, now we answer the question. What angle is the tangent to 0? Well, let's see. Well, we'll go through our 0 degrees. 0 is 1, 0. Tangent is y over x. 0 degrees. So there's one answer. 90. Tangent of 90 is not possible. Let's see. That's 0, 1. So y over x is 1 over 0. So that's not 180. 180 is a minus 1, 0. 0 over minus 0. Okay, so that checks. 180. 270, not possible. Therefore, we found the answer. Okay. Now, on your calculator, you will not, when you punch inverse tangent of 0, you only get 0 degrees. You don't get the 180. So we must know trig to get the other part of the problem. All right, tangent theta is a minus 1. So let's see, minus 1, that must be 45. Tangent of 45 is 1 over, okay, so that's 45 degrees. But is it 45 here, 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 or here? Well, tangent. Tangent's negative. Tangent is y over x. Where there are opposite signs, that would be quadrant 2. So 45 there is 135. And quadrant 4, tangent's negative. So that's 315. And then go ahead and put these in ascending order, of course, for a final answer. But that's the process, all right? Okay, let's look at example 7. Example 7 is the same as example 6 algebra. It is, we move this across and set it equal to 0 and factor or solve. So we get secant square root of theta minus 2 is equal to 0. So we set the secant of theta equal to 0, and we set the secant square root of theta equal to 2. I'm moving this across. So we take the square root of both sides, and we get plus and minus the square root of 2. All right, again, we mark this out because the secant is never less than 1. And then we work this one, secant, square root of 2. Square root of 2 sounds like the 1 square root of 2. Secant of 45 degrees is, secant is hypotenuse over j. That's it. So it's 45 degrees. Now, 45 degrees here, 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 and here, all of them. Positive square root of 2 gives us, see, secant is r over x, so that's these two. The positive square root are these two. And the negative are these two. So therefore our answer is 45 in quadrant 1, 45 in quadrant 2, 45 in quadrant 3, and 45 in quadrant 4. All right, example 8. All right, example 8. Now, this is a different situation here. We don't have a square term, so we can't use an identity. This is not, if this was secant, I could use the identity 1 over cosine and then work it that way. But it doesn't work. No identities here. So here's what you do. You take the sine of theta and you move the other across. This is just something you have to learn when you have different trig functions that are not connected, they're not reciprocals, and they're not squared. So that's the process. And then we divide both sides by the cosine. And so we end up getting the tangent of theta is minus the square root of 3 over 2. Square root of 3. Just minus the square root of 3. Okay. Now, some people work this by squaring both sides, this type of thing, but that, and then changing this to cosines, or this over here to sines, and then work it. But when you square both sides of an equation, you add in answers. Not always, but most time you add in what are called extraneous roots. They work the squared equation, but they don't work the original equation. So that's not the best way to do it. Now, when you divide both sides here, then you stand the possibility of an answer not working because you make the denominator 0. Okay, in other words, if this come out to be like a 90 degrees, and when we work this out, the cosine of 90 is 0, so that wouldn't work. We could not divide the 0 here. But in this case, it doesn't, so we're all right. So what angle is the tangent square root of 3? Well, we go to our 1, 2 square root of 3 bit. Tangent of 30 is this over, that's not it. The tangent of 60 is the side opposite over the side adjacent, so that's 60 degrees. So our angle is 60 degrees. Well, wait a minute though. 60 degrees here, 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 and here. Tangent's negative. Tangent's y over x. Y and x are opposite there, so it's quadrant 4. 60 degrees there is 300. 60 degrees here is 120. Now let's look at example 9. All right, example 9. This one just a lot of math here, trig. Here we go. We have this squared is equal to that squared. So we square both sides. So this becomes 1 plus 2 cosine of theta plus cosine squared of theta. Okay, first times the first, that, last times the last, that, inside doubled, okay? All right, this one's squared, minus times a minus is a plus, square root of 3 times square root of 3 is 3, and sine squared. What's the rule? All same word, all the same word. Well, this one has a cosine of the first power, we can't change it, but this one we can change with an identity, so that's what we'll do. So we'll write this as 1 plus 2 cosine of theta plus cosine squared of theta, and we'll change this to 3 times 1 minus the cosine squared of theta. Trig identity, sine squared is 1 minus cosine squared. Well, let's see. Now, here on the tape, I'm going to go ahead and do it this way. In the notes, it takes another step. I'm going to multiply everything with 3, so it's going to 3 times 1 is 3, and 3 times the cosine is minus 3 cosine squared. Now what do? We move everything to one side, set it equal to 0. So moving this across is 3 of these, which makes 4 cosine squared of theta. And then we have the plus 2 cosine of theta. And then we have the 3 moved across becomes a minus 2 with this plus 1. All right? Moving the cosine squared goes to that. Moving the 3 to that goes to minus 2, and then we have the 2 cosine of theta. Well, let's factor 2 out of that. And so we have 2 cosine squared of theta plus cosine of theta minus 1 is equal to 0, and therefore we factor. If we can be done. All right, so this would be 2 cosine. Let's see, I have a plus in there, so let's make this a plus 1 and this a minus 1. Now double check your work. First times the first, yeah, that checks. Last times the last, minus times the plus, that's a minus. Inside's a minus 1, plus 2 of them is plus 1 of them, so it does check. Now, setting each factor equal to 0. Now watch this. Set this equal to 0, we get the cosine of theta is equal to a minus 1. Setting this equal to 0, we get the cosine of theta is equal to a plus 1/2. And setting this equal, no, that can't be the part that's equal to 0. There is a theorem in mathematics that says that if this factor times this factor times this factor is equal to 0, one of those had to be 0. Well, that can't be the one. So this one has to be the one that might be 0, so there's the work. Or this one might be the one that's equal to 0, therefore the work is. All right, so now we finish the problem off. For by what angle? All right, cosine is 1/2. Well, we go do our 1, 2, square root of 3. Cosine of 60 is side adjacent over the hypotenuse. Therefore, this is 60 degrees. And what? Well, cosine is positive here and here. So therefore, it's 300 degrees. 60 degrees here is 300 degrees. All right, cosine's a minus 1. All right, minus 1. Let's see then, minus 1. That must be these special angles. Okay, 0 degrees is 1, 0. Cosine is x over, that's 1, not a minus 1, that's 1. So it must be 180. 180 is a minus 1, 0. Cosine is x over r minus 1. So it's 180. So it becomes 180 degrees. All right, and then final answer, put them in order. But wait a minute. Let's go back and look at the entire problem. Okay? So looking at all of the problem, what we must do, anytime you square both sides of an equation, you better go check these in the original equation. Not in here, but you better go check it in the original equation. If I put 60 degrees, cosine of 60 is what? 1/2 plus 1, that's 3/2 squared. Okay? Over here, the sine of 60 is the square root of 3 over 2. Square root of 3 over 2 times square root of 3 is 3 halves. A minus 3 halves squared, that checks. Okay, so that's all right. 300 degrees. If I put 300 degrees in here, I get the same answer. If I put the sine of 300 in here, okay, I get a negative 3 over 2, but the negative times the negative is positive, so I still end up, when I square it, still checks. 180. Cosine of 180 is 0. Okay, so this is 0. That squared is 0. Sine of 180 is 0, so it checks. All right, so these are okay. Listen, if the problem had not been squared to start with, and we squared both sides and did all this work, then what happens is 300 degrees doesn't work. I'm sorry, the 60 degrees doesn't work. The 60 degrees doesn't work because this is a positive 3 halves and this is a negative 3 halves. So they would not have worked. So anytime you square both sides, now the problem starts out this way, it's okay. But anytime you square both sides of an equation, you better check the answers. All right, well, what I want to do on this is part 1 of this tape. And so if if this is far enough for you to see right now, then turn the tape off and work some of your homework problems. But I'm going to continue on this tape with part 2, and part 2 is going to deal where these angles are different angles, and so we have to come up with some more new rules. Okay, this concludes in part 1. Factoring from here leaves us a minus 2. Now we set this equal to 0. We set this equal to 0. Then we solve. That gives us secant square root of theta is equal to 2. And taking the square root of both sides, we get secant theta is equal to plus minus the square root of 2. All right, again, let's go back over here and look at secant theta equals 0. That is marked out because the secant is never less than 1. All right, looking over here, what is this one? Well, where is the secant? The square root of 2. Again, trying the 30-60 triangle. You don't have a square root of 2 on that one. Trying 45 degrees. This is 1 square root of 2. Secant is the hypotenuse over adjacent. So that square root of 2 over 1, that's it. So that is 45 degrees. Now, positive. Secant is positive. Secant is r over x. Where is that positive? That would be quadrant 1 and quadrant 4. So 45 degrees in quadrant 1 is 45. 45 degrees in quadrant 4 is 315. Then we do the negative. Negative the square root of 2. So, well, square root of 2 is still 45 degrees. Where is the secant negative? That's r over x. Where is x negative? X is negative in quadrant 2. That's the 135. And also x is negative in quadrant 3. That's the 225. Now again, let me caution you. If you don't understand that, stop this tape, rewind it, go back over these steps in here if you don't see what I'm doing. Because I must go on to continue the other examples. All right, let's look now at example 8. All right, example 8. We have different trig functions. But wait a minute, we don't have anything squared, so we can't use those identities. Because I've been saying that if you have the single power thing, we usually can't fool with those. We can't change them. So here we have kind of a special case. And there's 2 or 3 of those in your homework problems. And knowing most teachers, you'll get one of these on test. But this is kind of a special case that let's look at the next line now and see what we need to do with it. Here is usually the method to use. Not always. I'll show you the next example where there's another method to use. But usually this is the method when you have a single powers of different trig functions. We put one on one side and one on the other side. And then we use some kind of algebra. And what we're going to do this time is to divide both sides by the cosine of theta. Dividing both sides by the cosine of theta. And that divides out. And if you look at the next line, you have then the sine of theta over the cosine of theta is equal to minus the square root of 3. Now, one thing you've got to be sure to remember here is that when you're solving equations and you divide by unknowns, by these things that we're looking for, you stand the chance of dividing out answers. Also, you stand the chance of dividing when you should not have divided. For instance, what happens for this angle that makes the cosine 0? For instance, if this has been 90 degrees, what happens on 90 degrees? Well, I'm really dividing by 0, and I can't do that. Let me break in here for a moment and say this. What I'm telling you is when you start doing this process, then you better check every answer that you get. Back in the original problem. Back in the original problem. Now, I'll come back to that in a minute, but I want to break in now and warn you. Anytime you start dividing by the unknowns, you're taking the chance of dividing out answers, and you're also taking the chance of having answers at the end that do not work in the original problem. So be aware of that, and let's continue. Now, the next line, we have the sine of theta over cosine of theta is equal to the minus square root of 3. And what is the sine of theta over cosine of theta? That's tangent of theta. Okay, trig identities. You've got to know chapter 3 and you've got to know chapter 7. Alright, so tangent theta is equal to minus the square root of 3. What do we say? We say what angle is the tangent, the square root of 3? Well, again, drawing the triangles. The tangent of 30 degrees is 1 over the square root of 3. That's not it. Tangent of 60 degrees is the square root of 3 over 1. Side opposite over the side adjacent. So 60 degrees is the angle. Now, it's negative. Tangent is y over x. Where is that negative? Well, it's where these are different signs. That's quadrant 2 and quadrant 4. So quadrant 2, 60 degrees is 120. Quadrant 4, 60 degrees is 300. Now, we better check those in the original equations. Putting 120 degrees up here, we want this equal to 0. Putting 120 degrees up here, the sine of 120 is the sine of 60, which is the square root of 3 over 2. Quadrant 2 is positive, plus the square root of 3 times the cosine of 120 is 60 degrees. Quadrant 2 is negative 1/2. And this times that, added to this, is 0. So that checks. Trying 300 degrees, the sine of 300 degrees is, sine is negative. So that's a minus the square root of 3 over 2. And the cosine of 300 degrees is a positive 1/2. Because cosine is positive in quadrant 4. So this comes out to be 0. So our two answers then are correct. All right, let's look at the last one now. We have given this problem. Now here we have, again, single powers. But we have a constant involved here. And we can't divide both sides, or we're going to end up dividing 1 over cosine of theta, or 1 over sine of theta. So when we have single powers and with a constant on either side, we can't kind of divide it out like we did the previous example. What we do now is square both sides. We will square both sides. Here again, you stand the possibility of adding answers. So we're going to have to check our final answer. So let's continue through this one. Next line, squaring this would be 1 plus 2 cosine of theta plus cosine squared of theta. Squaring this would be a positive 3 sine squared. All right? Now, trig identity. Remember, we've got to get everything to be the same trig function. Single power here is cosine, so we better get everything to be cosine. That already is. Sine squared, looking at the next line. Sine squared is 1 minus cosine squared. All right, we have all that algebra. Now we're looking at the next line. We will remove the parentheses. 3 times the 1 is 3. 3 times the cosine squared is 3 cosine squared. Now what do we do on kinds like this? If it's all the same trig function, we move everything to one side. So moving all this over to the other side, minus 3 cosine squared moved over is a plus. Looking at the next line, we get a plus 4 cosine squared. Moving the 3 across, we get a minus 2. Now I'm going to rewrite this line. Looking at the next line, rewriting this in front, we have 4 cosine squared plus 2 cosine minus 2. Now what do? We factor. If it cannot be factored, we use the quadratic formula. All right, this can, I'll divide out here. Looking at the next line, what I did here is just reduce these constants. I divided everything by 2, so it looks easier to factor. All right, now factoring this, looking at the last line here on the board, right now we factor 2 cosine of theta minus 1 and cosine of theta plus 1. And now we have it to where we need to go. All right, looking over here, that then would make us cosine of theta equals to 1/2, and we'll have the cosine of theta equal to minus 1. Now, what angle is the cosine 1/2? Well, that's 60 degrees. Positive 60 degrees. And also, where is the cosine positive? Well, quadrant 1 and quadrant 4. So from the 1/2, we get 60 degrees and 300 degrees. Where is the cosine minus 1? Well, again, this is where we have to use our special angles. Trying 0 degrees, trying 90 degrees, trying 180. 180 is a minus 1, 0. Cosine is x over r, so that'd be a minus 1 over 1 is minus 1. So theta then is equal to 180 degrees. So the final answer then, again, I haven't done this in all these problems, but you should get in the habit of writing the final answers in order and then blocking that off. Now, remembering that when we get these answers, we've got to come back and check these in the original equation because we squared both sides. So let's take now 60 degrees and go back in the original equation. And I'll have to come back and erase parentheses I had here for squaring these because we must check in the original equation. Do not check it on anything that you work after that. So checking it in this original equation, if we put 60 degrees here, the cosine of 60 degrees is 1/2. 1 plus 1/2 is 1.5. So that's 1 1/2. If we put the sine of 60 degrees, that's the square root of 3 over 2. Square root of 3 over 2 times a minus the square root of 3 is a minus 3/2. Well, the 3/2 are the same, except this one's a minus. So, hey, we got to come back down here to the final answer and say, no, that didn't work. All right, so the next one we need to check is 180. Let's go back to the original equation and put 180 in here. Now, the cosine of 180 is minus 1 added to 1 That's 0. 180 here, the sine of 180 is 0 times this is 0. Hey, that checks. 0 times the minus square root of 3 is still 0. 0 equals 0. So come back down here to the final answers, and we will use, then, 180. That one's all right. 300 degrees. Let's go back up here to the original equation and look at it. If we plug in 300 degrees, cosine 300 degrees is 1/2, and it's also positive since it's in quadrant 4. So this is 1 1/2. And if we put the sine of 300 degrees, that's in quadrant 4, and the sine in quadrant 4 is negative, and so that's a minus 1/2 times the minus the square root of 3, minus the square root of 3 over 2, minus the square root of 3 over 2. The sine of 60 degrees in quadrant 4 is minus the square root of 3 over 2, times that's plus 3/2, and it checks again. So looking back at the final answers, we have then that the 300 degrees also works. So 180 degrees, and 300 degrees are only two answers to this problem. Let me say one more time that in these kind of problems, that you need to remember that if you square both sides or if you divide, you have possibilities of dividing out answers or adding answers to your solution. So let me go back to the last two examples. Let's go back to example 8, and let me say this, that when you divide, you remember that you cannot divide this if this function is a 0. In other words, if you use some angle. So you've got to keep in mind, you're saying, I'm going to divide this provided my angle is not a number that makes that 0. So this then concludes these problems. I hope that you will look at the next part 2 tape, to be able to work the trig functions that deal with different angles. Now, all these problems, we had different trig functions or the same trig function, and we changed it all to be the same trig function. All cosines or sines or tangent. Now, the next part, we're going to look at what happens if your angles are different. 3 theta, 2 theta, 4 theta, and we will deal with that and other examples.